this video is for people starting out in the trade, machinists that are in the mix, just grinding every single day, people opening their shops, and high-level production companies. We're going to take a common sense approach to purchasing tools. When do you actually buy just a regular carbide drill or a specialty tool drill? It matters because you might spend $30 on a drill or $200 on a drill. So when does it make sense to spend the money, and when is it okay to actually not spend the money and go the cheap way? Same thing with end mills and the same thing with boring bars. So let's actually break down each one, have a common sense approach to when and why you would use either one. You guys have a lot of experience in not only programming, but purchasing tools. And I think there's a lot of guys out there that, you know, they look at drills and they go to Western tools. Hey, what's up, Craig? But you go to different people out there and you say, hey, you know, how much is a carbide drill? How much is this? How much is that? And you look at the drills and you're like, oh, it's 20 bucks. That makes perfect sense for me. And if you have only 5 parts, it might make perfect sense. Yeah. But if you got 100 parts, you might want to go to a Go drill or an SGL drill, or you know, some of your other favorite drills and stuff. So when do we actually make the choice to spend the money?
Yeah, I definitely think it's a quantity type thing, and then even if it's a repeat job, you know, like, and not only that, it's safety too. You know, if you might have a super expensive part that, dude, I may only have 3 or 4 or 5 parts to make, but I also don't want to throw a general purpose drill that might blow out the hole, it might not. You know, maybe it's a material like copper or something that's 100%. Super expensive, it's gummy. Abrasive. Like, yeah, I want the drill that I know is going to work for that. That might be a high performance drill.
Absolutely. If you're dealing with material that costs $2,000, $5,000, maybe $10,000, you're not going to skimp and go easy, because if you break a tool, you basically scrap everything and, you know, wish that you would have went high end. And then you can actually come in with like through the spindle coolant, and when does that matter? And how, depending on like what material, how deep you're going and all that.
Yeah,
yeah, exactly.
Yeah, I've always looked at the number of parts I have to do, the number of holes that I need to make, and the accuracy that the holes need to have.
So when I would go and quote, I'd look at, you know, hey, I got 5 parts, and it's, you know, aluminum or steel or, you know, stainless, just pretty basic, nothing too deep. And if I don't need to spend the money, I'll just go with a regular carbide drill. And then in recent years with Kennametal, we went to the Go drill. That was a nice standard tool. Now let me actually break it down and explain exactly what I'm talking about. If you actually go to a regular off-the-shelf, just a standard no-name carbide drill, $30, $20. It's not expensive, and yet you can still, when you're going in aluminum, you're going in steel, basic steel and stuff, you can get feed rates of like 20, 30 inches a minute, no problem. Maybe 40 inches a minute, no problem. But when you jump up to a Go drill, and now instead of 20 or 30, you're paying $60, $70. Now this drill, you can actually go 60 inches a minute, 100 inches per minute. Then you can go to like a specialty drill, like an SGL for stainless or an HPX for regular carbon steel. And now you're going 100, 150, 200 inches per minute. And if you have 600 holes, if you have 1,000 holes, if you have thousands of holes, the runtime is actually going to make you money. It's going to make complete sense to actually do that. But if you only have 5 parts, you only have 20 holes, it does not make sense to actually spend that money unless it's a repeat, and a repeat.
And you do a lot of those same materials, because like you said, a SGL that's good for stainless, you know, you might get into a situation where I'm a job shop or I'm a reman shop. A lot of us come from that world too, that, hey, if I do every material under the sun, I might be doing aluminum, cast, steel, stainless. You know, you might not want to stock a high performance drill in each material. And you might can get by with something like a Go drill. That's why one of the reasons why the Go drill is such a good drill is it is a universal coating on there, so you can do all kinds of material.
Plastic, aluminum, steel, stainless, Inconel, Monel, everything, the entire gamut.
Yeah, and you're not going to get the accuracy like a 4 margin drill is going to give you. So if you might need that, you might have to go to a drill like that. But I mean, blowing holes for clearance for bolt holes, it's going to do it all day long.
Yeah.
And those Go drills last forever. Like, you remember that guy in our Facebook group got 196,000 holes off one tool?
It's crazy. And we did some cool videos just showing like how many holes you can do and all the different materials and stuff. But again, specialty drills will actually take it to a higher level. Now, kind of common sense, if you don't have a lot of different holes, then maybe you can get away with regular carbide drills and inexpensive drills, especially if you're on like an odd size, like a .3245 or something, like just some oddball for one particular job for one particular hole. But if you're actually tapping a ton of quarter 20s or 1032s or 832s or metric, whatever the drill size is for that drill, I would go and actually get a high level drill, at least a go drill, and stock that for all threads that you do, so that every time that you actually put threads in a part, you're efficient in your hole making, and that'll save you time across the board. And over the year, you will save crazy amount of hours and all of that, right?
Yep, and that's what it's all about, cost per hole.
Awesome. Now, next thing we should talk about is end mills. So there are a million different types of end mills. There are amazing, great end mills. There are subpar end mills. There are just regular, standard, cheap 3-flute carbide end mills. And then there's 5-flute, 8-flute, 13-flute. When do you buy what? So I think when it comes to just standard, you know, you got a few parts here, a few parts there, running a regular 3-flute in aluminum, no issues, right?
Yep, no problem. Unless you don't have a lot of torque on your machine.
Exactly. So one of the things that I noticed on, and this is actually kind of cool, is the new X9 that we got. We went ahead and we actually started, I didn't actually look at the torque chart, the horsepower chart, and we went in with a Core 5 and we put it at 11,000. It's a 12,000 RPM spindle. Put it at 11,000, it was a 1/2 inch end mill. We went 1.4 deep, 10% in. And then as soon as we started cutting, it was like, first cut was 100 inches per minute. And I looked at it and I was like, whoa, it's got some load on it. And that surprised me because that's a high RPM spindle. But also some of the customers that actually purchased the machine, I remember them saying, man, this thing kills it in steel. So first thing I did was like, hey, Steven, go grab me that chart right there so we can check out where the horsepower is at and all of it. A lot of times you look at a spindle and it's 12,000 RPMs and you'll see that it'll actually drop, like from the very low RPMs, you'll see it. It'll be way down here and then it'll kind of go up to maybe 8,000. It'll kind of peak. And then from like 10 to 12, it'll start dropping down and you'll be like, okay, this is where the power's at. If you go to like a high horsepower, low end RPM spindle, you might be more like up here and kind of go up here. And then at 2,000, it starts dropping to 6,000. Well, this one I actually wanted to test. So before I even got the numbers, we were just running back and forth. I'm gonna put it in a video. We were running back and forth and then I started running faster and faster. Now remember, it's a 5-flute tool, but I started slowing down the spindle. Even every time it would come out of the material, I'd slow it down, 10,000, 9,000, 8,000. It was like, brr, brr, brr. But guess what? The spindle pressure actually came down. So all of a sudden, I was at 5,000 and it had hardly any pressure on it. So then I went up to 200 inches a minute, 300 inches a minute, 327, and it was just like, like no problem. And then that told me before I even saw the chart, oh, this thing has low end power. But it's cool because if you have smaller tools, you can go to the higher RPM, and that's the first thing you do every time when you go to a Heller, you go to any big machine or you go to any machine, you figure out what the horsepower, what the torque, and where it should be, right?
That's actually a perfect example of matching the tools with your machine.
Yeah.
Because like you said, like more flutes, because with that machine, where the torque and horsepower is the best at, you're not going to get the RPMs with that much horsepower torque, so it's on the lower end.
Yeah. So
like you said, in order to keep your MRR up, think about going to even a bigger tool, but more importantly, something with more flutes.
Exactly.
That way, when you're having to run at that lower RPMs to get the horsepower, you can still keep your MRR up because you got the flutes to compensate.
100%. If you had a 3-flute and you're at 5,000 RPMs, you might be at 100, 200 inches a minute. And because it's only 3 flutes in cut, you're limited to how fast you can go, but adding 2 more flutes to the cut just allows you to go that much faster and get that MRR. And then you're looking at it and you're saying, hey, the power is actually on the low end. Now, whether it's a small diameter or a large diameter, per revolution, if you go to a shell mill, you have greater surface area, so there's actually more speed in the cutter. So sometimes you might look at it and say, you know what, maybe I'm gonna go to, instead of an end mill, I'm gonna rough with a shell mill, go down 100 thousandths, but take, if it's like a 3-inch, take like a 2.8 cut on it, and then keep it on the low end, which actually is kind of weird, right? Because you can be at 4,000 RPMs, but if it was a 1/2-inch end mill, it's more like you're running at 12,000 RPMs based on the diameter and the rotation. And so you can actually get a greater MRR with a shell mill than an end mill in certain cases, right?
And another thing to look at too is the types of material that you're running. Like if you're just running carbon, steel, stainless, aluminum, a lot of times a general purpose end mill is going to be fine. But when you start getting into the high temp alloys and stuff, then you have to start buying special cutters.
Yeah, 100%. And that's why we love the Harvey 3 end mill, the zombie mill,
Yes.
you know. A lot of people say like, well, it's because you're a partner with Kennametal. At the beginning, I was not partnered with Kennametal. I tested every single tool. Everybody was giving me tools to sample. Of course, I purchased them after they work, and everything was dying in Inconel 718 within like 30 minutes. Everything was dying, and we're trying to like get all this material off, and then all of a sudden you go Harvey 3, 7 hours, and that enabled us to start loving on Kennametal and be like, oh, this is a different level tool. And then you come with the TE for like just, you know, helically down and just full slotting and doing all that. So not all tools are equal. You got to look at what you're making, how many you're making, and then the level of material, you know. There's so many different machinists out there. Everybody at some point can make a part, but then it's like, what tolerances can you keep? And then what are the levels of material that you can actually run and still keep those tolerances and make perfect parts efficiently. And that's why I love manufacturing, because no machinist, you're gonna be different, I'm gonna be different, you're gonna be different, you know what I mean? And you guys are gonna be different. I love, throughout this entire conversation, I love you guys to actually put your experience down, and if you got comments on the different types of tools and stuff, the same thing. So like we were saying about the 5 flute, imagine with the power and you're at 5,000, a 2 flute just wouldn't make sense because it can only go so fast. So at the end of the day, really look at where your power's at, how much material you have, what type of material it is, what's the production look like in the future, and purchase based on that. And as you make money, then spend money. A lot of times when I quote jobs, I'll actually put the cost of certain tools into the quote. I'll call it an NRE charge, non-reoccurring estimate. And basically I'll tell the customer, hey, you know what? Everybody else is doing it like this. I'm actually gonna use these tools, and these tools are gonna allow me to be 40% more efficient. So I'm gonna actually put the tools in, we'll have them for the next run, and therefore I can drop the cost of the part overall forever because of the approach and mindset of how we're actually machining the parts. Yeah. All right, so we just talked about drills, we talked about end mills. Let's go quickly to boring heads. Now, boring heads, for anybody starting machining, starting their own machine shop, boring heads are scary. You know why? Because they are expensive. Once you step into a good quality boring head, you're talking thousands of dollars, and then all the different sizes and the inserts and everything. So when do you actually go from, you know, making holes and saying, hey, I actually can't use an end mill, I have to go up to a boring head? When do you make that adjustment?
And I think that comes down to quantity as well, and not only quantity, there's a lot of things that factor in there, but even like the depth of the hole.
Quantity and tolerance. Huh?
Yeah, tolerance, quantity, the depth of the hole, like, you know, because a lot of times what I've done in the past is, you know, I've made a lot of very tight tolerance parts that have some really tight tolerance on like locating holes and stuff like that. I had only 5/10 total tolerance, you know, on the diameter. But you know what? I'm not going to go spend $3,000, $4,000 on a boring head when I'm only making 2 parts. Yeah. You know, at the end of the day, if I got to spend a few extra minutes working that end mill to size by helical boring down, I mean, who cares?
Absolutely.
You know,
absolutely.
Versus the price of the boring head. But like, But if I had 100 of those parts to make, 200 of those parts to make, depending on the price of the part, yeah, then it makes sense for me to go and spend the money up front to buy that boring head, put it in. Now, once I set it the first time, I don't have to worry about it 100%. Until that insert starts breaking down.
I think that when you look at it, I think tolerance, if you have like plus or minus a tenth, right, or 2/10, now you're getting into some crazy tolerances, and you got to make sure they're perfect. If you have like plus or minus 5/10, and the hole is less than 2 inches deep, then you can pre-drill and just do a helical down. Now you're gonna have deflection with an end mill, so of course you wanna make sure that you got a good rigid tool holder, a good spindle, you got the RPMs at the right level so you're not chattering too much. You know, I mean, I wasn't looking at Barry for any particular reason, I just happened to, but you need to, like, a lot of times your RPMs, like on that first one, you'll be kind of fast and just like, and then pop back up, maybe take a little cut, and then come, like, slow it down, make it nice and rigid, come down, and right there you're gonna have some deflection in it, but then you just do a few spring passes. For those that don't know spring passes, that's just taking the exact same cut a couple of times, which allows the end mill to relax itself and basically cut at the bottom so you have a perfectly straight wall. So doing that technique, you can actually get a lot done pretty fast. Pretty fast, but once you go deeper than a couple inches, depending on the size end mills, now you get into bigger end mills, longer end mills, more deflection. Once you go deeper, you're at 2 inches, 3 inches, 4 inches, 5 inches, then you definitely want to go to a boring head. And a good investment in a boring head for any shop is extremely important, and you can sell your customers on it too. Whenever customers are coming to the shop, I'd be like, I'd go to the tooling, I'd tell them why we're efficient, how we keep the tolerances, how the inspection works, how we're 100% inspection on every single hole in every part when it comes to tenths, anything less than plus or minus 1, you know what I mean?
And you don't have to make the jump straight to a reamer right off the bat. I mean, a boring head right off the bat. You could ream the hole if it,
Absolutely.
you know, if it lends itself to being able to be reamed. But the problem with a reamer, then it's going to follow that drilled hole. So maybe you're in a point where you got a deep hole that has to be completely accurate. Maybe you got a really tight true position tolerance. So that's when you really want to go to a boring head.
Yeah, 100%. And reamers will be an exact size for an exact hole. They're not universal to multiple, where if you get a good boring head, there'll be a range of it. So if you get one that's like 1 inch, you'll probably get something, you know, that's like 9 something to 1.2 or something, depending. And then you size up from there. But once you get kind of like starting the kit, then it gets kind of cheaper as you go, because now you're adding to it and stuff. Yeah, you've done some pretty crazy bore holes, right?
Yep, we've done a lot of different tolerance holes. And for me, anytime I see something that's tighter than plus or minus 5/10, then I start looking at things like specialty drills, reamers, and then boring heads, usually based on the depth of the hole.
So at the end of the day, look at the application, look at the quantity of parts, look at your tolerance, look at the material, and basically spend the money that makes sense based on the job and application that's at hand. When you got a lot of parts and you got heavy materials, or you got just a ton of holes, then go ahead and go to a top level drill so you can actually just murder material, get after it, be efficient, and make money for your customers and your company. If you only have a few and you're just starting out, it is okay to just get a standard off the shelf, less expensive drill. And again, I want to say, everybody out there, I'd love to hear your experience. What do you guys think on the whole subject? What are your favorite tools? Let us know what your favorite tools are. Let us know how you've saved money, and let us know like how your mental approach. I always say this game is about levels, and it's about the mindset of the machinist. And based on your mindset and your talent, your company is going to do great or it's going to suck. And the lead programmer dictates the pace of the entire shop. So take it to greatness, get after it. Love working with you guys, man.
Yeah, same.
Boom. And remember, go to titansofcnc.com, check out all of our free academies. All education is 100% free, and you can get certified on cncexpert.com. Our app is almost out. It is amazing, and it's going to change the entire world. Boom, we're out.